Now the last cheat code I want to talk about in detail in this unit is the chain rule, or as I like to call it, the buried function rule. Let's say our function y was something like cosine, but not just cosine of x. What if it was cosine of x cubed? Well, this is a fun little problem. I can't use the product rule in this because it's not like one function times another. It's actually one function inside of another. So I have to use what we're going to call the chain rule. And the chain rule says this, kind of in an informal definition. I want you to think of this as an onion with inside layers and outside layers. And the outermost layer is, of course, the cosine layer. And I'm going to put that in white here. And then we have an inner layer, which is our x cubed layer. The chain rule says you need to take the derivative of the outermost function first. And in this case, the outermost function is cosine. And the derivative of cosine is negative sine. And I'm just going to leave that kind of in white there. Once you've taken the derivative of the outside function, then you can take the derivative of the inside function. And the inside function here was x to the cubed, its derivative just being 3x squared. And you multiply those two results by each other. Now, of course, the question is, what do we put in here? You just put in there what started in there, which was x cubed. Okay? So the idea is you take the derivative of the outside function and you leave the inside function alone. Then you go ahead and take the derivative of the inside function. And that would be our derivative. Another example. Let's say we had y equals e to the x to the fourth. Okay. Again, this is not the same as this function, e to the x times x to the fourth. In this case, we could use product rule because we have one separate function multiplied by another. Here, our x to the fourth is inside the e function. It's up in it, you could say. So our derivative, we have to use the chain rule. So let's think about this as a color-coded outside layer and then our inside layer. So the derivative of the outside layer, well, that's easy because it's e to the x. So I can just say it's e to the x. But our x in this case is x to the fourth. So that's the derivative of the outside layer. Then the inside layer, being x to the fourth, has the derivative for x cubed. And that would be our y prime. Y prime is the derivative of the outside layer times the derivative of the inside layer.